Math 1332, Chapter 3, Symbolic Logic, Section 2, Truth Tables, Video 4, Truth Table for Conditional. Just to let you know, we've got this truth table, and then we've got the next one for biconditional, and that will be the rest of our basic truth tables that we're going to use to build other truth tables. After that video, we'll just do several examples because this is the type of thing that requires several demonstrations for people to start latching onto. And then at the end, we'll show a special case where we don't want to necessarily calculate an entire truth table, but rather just one particular line for one particular situation. All right. So, well, this is going to be round 3. This is going to look like the previous 2 videos, except when we populate the last column of the truth table, we're going to have to do a little bit more thinking. Recall that a conditional is the phrase if then when used to connect 2 statements into a larger compound statement. The symbol for conditional is an arrow pointing to the right. And in case you're wondering, is there something meaning with an arrow pointing to the left? The answer is yes, but we don't get to that in this course. To construct a truth table for conditional, we start with the generic conditional written symbolically, so it's going to be P pointing to Q. And you may be thinking, wait, on the previous 2 videos, you didn't have more stuff down here. That's because now is the good time to officially introduce the new definitions, the definitions of the words that I've been using in a previous video in this series and even one in the previous series. In a conditional, in the conditional P arrow Q, the P is called the antecedent. Now, it's not always the letter P, but it's based on its position, the thing on the left side of the arrow. And the Q is called the consequent. In the context of the actual phrase if then, the antecedent is the statement that follows if, and the consequent is the statement that follows the word then. Remember that sometimes in a conditional, the then isn't stated explicitly, but it's implied. Since the compound statement contains 2 simple statements, P and Q, our truth table will start with 1 column for each. The final column will be just for the conditional. So just like before, and you should know what's going to happen now. Next, we populate the first 2 columns with every possible combination of truth values for P and Q. Do you know them by now? The order in which I'm going to do them? What's the first one? True, true. Second one, true, false. Third one, false, true. And then the fourth one, false, false. I want to reiterate that technically speaking, it does not matter what order these rows are in, but for consistency, whenever I do a truth table for a compound statement that involves only 2 simple statements, I will always populate the first 2 rows like that. All righty. To determine the truth value of the conditional for each row, let's consider a specific case. Now, I know what you're probably thinking. P is I am female, Q is I was born in Texas. Well, I'm not using that this time. I'm using something that I alluded to in the first video. We're going to let P equal I win the lottery and Q equal I will marry my fiance. Because remember, in that first video, we kind of posed the question, when is this conditional statement true? If I win the lottery, then I will marry my fiance, based on whether or not I win the lottery and whether or not I marry my fiance. Now, before we jump into this, let's think about this realistically. Let's say that you are engaged, male or female, doesn't matter, and you tell your fiance, if I win the lottery, then I will marry you. And maybe we should say marry you right now, because sometimes marriages are postponed for financial reasons. But let's just say that you tell your fiance, if I win the lottery, then I will marry you. What would have to happen for your fiance to call you a liar? In other words, what would have to happen for you to have broken your promise? I promise you, if I win the lottery, then I will marry you. What would have to happen? Think about it. All right, let's go row by row like we did before. First row. The first row is when both are true. So I win the lottery is true. I won the lottery. I married my fiance. So if I win the lottery and then I married my fiance, was I telling the truth when I said, if I win the lottery, then I will marry you? Of course I did. I won the lottery. I followed up by marrying you. True. So if both halves, if the antecedent and the consequent, told you I'm going to use those words. If the antecedent and a consequence of a conditional are true, then the conditional itself is true. What about on the second row? True, false. What if I win the lottery and then I don't marry you? If the person who says the compound statement, so let's go back again. Fiance, if I win the lottery, then I will marry you. What if the person who says that wins the lottery and doesn't marry his fiance? Did he say a true statement or a false statement when he said this? Well, if he said, if I win the lottery, then I'll marry you, then he wins the lottery and doesn't marry you, he's a liar. What he said was false. He broke his promise. So, in a conditional, when the antecedent is true and the consequent is false, it's almost like you didn't follow up on your promise. And if then is kind of like a promise. I promise. If this happens, then that will happen next. If I win the lottery, then I will marry you. I promise. But if I win the lottery and don't marry you, that made me a liar. All right, let's go to the third row. Now, this one's a little tricky to figure out. Third row, which is antecedent false, consequent true. Let's say I tell my fiance, if I win the lottery, then I will marry you. And then I don't win the lottery, but I marry you anyway. Did I lie? I promise you, if I win the lottery, then I'll marry you. Oh, no, you didn't win the lottery. That's okay. Still going to marry you. Oh. Did he lie when he said, if I win the lottery, then I will marry you? Believe it or not, the answer is no, he didn't. Because he only said what he would do if he won the lottery. He didn't say what he would do if he didn't. He only said what he would do if he did. So when you see a conditional, if this happens, then that happens, and then the first thing doesn't happen, you're not obligated to follow through with anything. You can, you can't, doesn't matter. Because you didn't say what you would do if it didn't happen, you only said what you would do if it did. So even though he said, if I win the lottery, then I will marry you, and he didn't win the lottery, but he still married her, he didn't lie. Because he didn't have a chance to break his promise. The only chance he had to break his promise was when he won the lottery and didn't follow through with the marriage. So when the antecedent is false, but the consequent is true, the conditional is actually true. Again, that's because he had no opportunity to break his promise. The if part never happened, so he wasn't committed to following up the then. He did anyway. Last row. What if they're both false? What if I said, if I win the lottery, then I will marry you, and I don't win the lottery, and then I don't end up marrying you? Did I break my promise? Meant to uncover that. If the person who says the statement doesn't win the lottery and doesn't marry his fiance, is he saying a true or false statement? Honey, if I win the lottery, then I will marry you. Okay. Dang, I didn't win. Honey, I didn't win the lottery. I can't marry you. That's okay. At least you didn't break your promise. So believe it or not, when both halves of a conditional are false, when the antecedent is false and the consequent is false, you did not break your promise, which means that your statement was still true. This last one really throws people for a loop. How can the whole statement be true and both halves of it are false? Because you didn't break your promise. Remember earlier when I asked you before any of this was uncovered? You can go back, I forgot how long ago it was, but before any of this one covered, I asked you what would have to happen for me to break my promise to you. Honey, if I win the lottery, then I will marry you. What would have to happen for me to have lied, to have broken my promise? I would have had to won the lottery, but not follow through on my promise. That would have made me a liar. So it takes a little thinking to figure out all of this. The first one's easy. The second one's not too bad. You broke your promise. You lied to me. What you said was false. The last two are actually true, because the last two, you had no chance to break your promise because the antecedent never happened for you to follow through with what you promised in the consequent. So, based on the previous example, we have the following truth table for conditional. As before, the first two columns in this table will always be the same. Anytime you're doing a truth table for a compound statement that involves two simple statements, the first two columns will always be all the possible combinations of true and false for those two simple statements. And mine, and in the homework for the class I'm currently teaching, the rows will always be in the same order. True, 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 false, false, true, false, false. It's the last column you have to focus on. So what do you notice about the last column? It's mostly what? It's mostly true. In fact, the only time it's not true is here. So when you make up a rule for a table, you should make up a rule for the exception. It's always this, except when that happens. Well, this is the only row where a conditional is false, when the antecedent is true and the consequent is false. And that is the rule for conditional. A conditional is false if and only if the antecedent is true and the consequent is false. Now, there's another way to think about it when T points to F, because after all, we're saying that the only time it's false is when this is true and this is false. So this is the only conditional with T's and F's that ends up being true. That is what I call the broken promise. So in the future, when we evaluate truth tables columns and we're at a conditional, I will ask you, do you remember what the broken promise is? The broken promise is when the first part was true, but you did not commit to the consequent, you broke your promise. Know this table, or more importantly, know this rule. And in the future, I will refer to it as the broken promise.